are you?
Good. So, what are we doing today?
I've been having trouble taking stuff from like Vertex form and intercept form and putting it in standard form.
Okay. There's vertex form. Okay. Standard form is AX plus, talking about a quadratic. Standard form is y equal ax squared plus bx plus c, right?
Yeah.
So let's just expand this and simplify it. And then we'll be able to sort it into that standard form. So this is vertex form. Standard. So let's expand this out. What's x minus 3 squared? And that's what we need to do first. In other words, just follow PEMDAS. We're going to do the parentheses and exponential first. So it's 2 times what?
Wait, you don't boil it?
You do.
Oh.
In other words, yeah, our first step is to do this. However, you want to get to where you memorize that. In other words, we're talking about a very special condition. We're talking about a minus b quantity squared. And the reason I want you to learn it this way is because it saves you quite a bit of time from going through the foiling process. If you foil it, that's what you get. But so often do you have to do this that it's worth just memorizing it so you don't have to foil it each time. And the other end of that is a plus b squared gives you almost exactly the same result, only it's a plus sign in the middle. So, do that operation based on one of those instead of foiling it.
Alright. So it'd be x squared minus 2x.
2 times 3 times x.
Oh.
In other words, 2ab, a is x, b is 3. So that's minus 6x. What's the last term?
9.
Plus 9.
Plus sign.
Plus 9. You need the plus sign there. And we still have this plus 5. Okay? So the first step, relatively easy. And do try to memorize both of these. Now what next?
Now don't you multiply everything in the parentheses by 2?
Yeah, you distribute the 2. In other words, we're still doing PEMDAS. We're still trying to get rid of the parentheses. And now finally, we're almost in standard format. We just have to combine our constants. There you have it.
Alright.
Okay. Now, let's take one that is in Vertex, or y-intercept, x-intercept format, excuse me. Suppose we have 3, do you have one, or you want me to just make one up?
Just make one up.
Yeah, I don't see what difference it would make. There is intercept format, right?
Yeah.
Okay. Well, same thing. You can multiply that times that, and then multiply the whole result by 3. Or you can distribute that 3 and then FOIL the remaining 2 terms. Personally, I think it's better to do the FOIL first. It is less likely to result in mistakes, I think.
Yeah.
So what is x minus 3 times x plus 5? It's just, okay, so let's start with x squared. Let me help you a little bit on foiling. Let's try to do the next 2 steps in one step.
Yeah. So it would be
Outside,
2x.
inside. Yeah, there you
What?
go. In other words, we're doing the outside and the inside in one step, which is minus 3x plus 5x gives us 2x. Rather than constantly having to write that as 2 terms, it's not that difficult to learn how to do it in one step, and it gets to the result more quickly. Okay?
Yeah.
Now, distribute the 3.
So 3x squared plus 6x minus 45.
Okay. That question in your voice, guess what? I found the perfect program for you. And about 6 of my other students. I've been looking for this program for 2 years, and I never found it. And because most of the flashcards online are positive numbers only. You don't have negative numbers, and that's what everybody needs practice with. Let's just do about 5 minutes of this, and then I'll send you this link, and you can just do this 5 or 10 minutes every night, and I guarantee it'll improve your math amazingly. Tell me these as quickly as you can, without a calculator.
2. Negative 3. Negative 5. Negative 8. Negative 5.
That's minus 7 dividing into minus 14. Really a weird way to write it, but that's what they did.
2.
Good.
Minus 4. 10. 3.
Okay, you're better than I thought you were.
Negative 2. 56.
Okay, the only reason I brought this up was the question mark in your answer of the last one. In other words,
4.
you said 34 or something like that, which means you're not 100% certain. But it does look like you don't, the negative signs don't give you any problem. What's this?
Negative 9. Yeah.
All right. Negative 12. Okay. This is pretty cool because it mixes them up and it does the most important practice, which is single-digit multiplication, division, addition, and subtraction using positive and negative numbers. And that's what I've never found before. So let me just lay this on you. Not that I think you need it that much. If you go over to the chat window and in the GoToMeeting panel and click on that link, it'll open up on your computer, save it as a favorite, and anytime you just want to practice your math a little bit, I'm saying that no matter how good you are, the fact that there's a slight question in you as to the correctness of your answer, 5 minutes a night on this thing will cure you instantly in about 2 weeks. And you will be much better on those processes. And you can see how frequently we end up having to use those processes. I mean, look at this problem right here. We had to multiply 1 by 1. We had to add 5 and 3. We had, in other words, you're just constantly doing arithmetic when you do algebra. And the better you are at it, the much better off you'll be. Now, I personally think your skills are pretty good. You're not one of my students that desperately needs that. But I have a lot. You'd be amazed. I have a lot of Algebra 2 and pre-calc students that need that. They never really got really good at their multiplication and division.
Yeah, because they never really taught us at school.
Well, and you've lived with calculators. Really? I think the bigger issue is the calculator, because you want to be 100% certain, and most people who want to be 100% certain go to the calculator because they know that'll give them the answer. The problem is when you do that for any length of time at all, you lose the memory you had of the multiplication and division tables. So that's an important skill not to lose. So it definitely helps to do this stuff in your head, as opposed to having a calculator in front of you, and you don't want to have to multiply 3 times 2 on a calculator. You know what I'm saying? That would just slow you down immensely. All right. So those 2 problems, have we cleared them up?
Yeah.
Converting vertex and x-intercept form to standard is actually pretty easy. The difficulty is going the other way. In other words,
can we do a couple of those?
Yeah. I can make them up, but do you have any?
No.
All right, let me make them up. Let's start with an easy one. There's standard format. Let's put that in vertex format. Which is y equals a times x minus h squared plus k. So that's what we got we got to have this thing end up looking like that. So this is the key element that we have to convert to. What does that call for? What do we have to do?
Do we factor out?
No, this is where you complete the squares.
Oh, yeah.
Right? In other words, the reason is because we want this thing to look like x minus some number quantity squared. And whenever you have to do that, that's a complete the squares problem. Okay? So completing the squares, I separate the 2 terms with x, put parentheses around it, leaving space to add something, put my 10 off to the side. Now complete the squares so that I can write this as x minus something squared. Remember how to do it?
Don't you multiply everything by 2?
No, you take the coefficient of the x term, divide it by 2, and then square that result.
So 1.
So, you always add that number inside. Okay? And that makes this thing x minus 1 squared. Now, because I added 1 here, I have to subtract 1 there. Otherwise, I've altered the function. In other words, if I start with that, I got to maintain the truth of that the whole way. So I can't just arbitrarily go adding 1 without subtracting 1 from the same side. Now I've got plus 9, and that's vertex format.
Alright.
Okay, now let's make it slightly tougher. Let's put a coefficient in front of the x and that x. So now, in order to complete the square, I still start out doing this. But now there's a problem. You can't begin to complete the square until you've forced the x squared coefficient to be 1. So what's my next step?
Divide 8 by 2, then square that, so...
Oh, no, hold on. I got to get this coefficient to be 1. How do I get that to be 1?
Divide everything by 4.
Yeah, factor out a 4. In other words, take what's inside the parentheses here and take a 4 out. Not the greatest common factor. I don't want to take an x out. But I want to leave that. Okay? Now what? Now I'm ready to complete the square inside the parentheses.
Divide 2 or negative 2 by 2 and then square it, so 1 plus 1.
Now what do I have to write over here?
Subtract 1.
1? When I wrote 1 in there, how much did I add
4.
to the right side of the equation? That's right, I added 4. So you always have to multiply whatever this number is by the coefficient that you factored out. So now it's 4, and how do I write this?
X minus 1.
Right. It's always whatever half of that was is what goes there. Quantity squared plus 6. Now notice that that's vertex format. A is 4, H is positive 1, and K is positive 6. Okay?
Yeah.
And these do not have to be whole numbers. I could have made that a 7. Okay, what happens? Well, now when I factor out a 4, I don't have 2 here. I have minus 7/4, right?
Yeah.
In other words, fractions don't change anything. You still do exactly the same thing. I'm going to take half of 7/4, which is 7/8. I'm going to square it, and that's 49/64. This down here is going to become minus 7/8, and 4 times that number will be what I have to subtract from the same side. So no matter how complicated your original standard form is, you can always do this factor out the coefficient of x squared and then take half of that and complete the square. In other words, you can always get it into vertex format. Now, let's talk about getting standard format into x-intercept format. Now, when they gave you x-intercept format, do they use different letters? They do, don't they? Don't they use P and Q?
Yeah.
Okay. This is an easy one because it happens to factor. In other words, if I factor that, it's x minus 5 times x minus 2. Well, guess what? That is x-intercept format. So, what if it's not so factorable? What if it's that? Now how do we get it in x-intercept format?
Could you do the quadratic formula?
That's the only way you can do it. So x is going to be what? Just give you some drill here.
Should I give you the just normal form?
General. I'm pretty confident you got that memorized pretty good. So just give me the plug-in.
7 plus or minus the square root of, or just 49 minus 419 over 2.
Okay. Simplify that.
6. So 7 plus or minus square root of 13 over 2.
And let's come up with specific answers.
So 7 squared plus or minus.
No, hold on. Yeah, you're probably confusing it with that 2 right there. Let's erase that level there. So it's 7.
Plus or minus.
No, let's separate it into 2 answers.
Oh, yeah, plus.
Plus 13 all over 2.
2.
And 7 minus square root of 13 all over 2. So how does that translate into that? Well, here's how it translates. There's no a, but it's x minus this 7 quantity, 7 plus root 13 over 2, times x minus the bottom answer, parentheses, 7 minus root 13 all over 2. Whoops, hold on. Yeah, 7 minus in both cases. Now, when I remove the inside parentheses, this basically has the effect of making this minus and this plus. So it makes that a minus when I remove this parentheses, and when I remove this parentheses, it turns that to a plus. So there is vertex format right there. And that's why I wanted you to break the whole quadratic down to the 2 solutions, because in order to put them back into linear factors, you need to know precisely what they are. Now, I'm not sure they'll ever make you do this, where they might make you convert standard format to x-intercept format if it's factorable. In other words, if that was a 10, like it was, then they probably will make you do that. And of course, if, let's make that 2, 14, 20. So if that was the question, which is far more likely to be one you'd get, then the first thing I can do with that is factor out a 2, right?
Yeah.
Leaving behind this, and then when you factor that quadratic, you have the 2 times x minus 5 times x minus 2, and there is x-intercept format with an a that's not 1. In other words, a is 2 here.
Yeah.
So I suppose you always factor out a number if you can from the standard format quadratic, and that will end up being a.
Yeah, that makes sense.
So how you doing in your math? Have things gotten better? What kind of
Yeah.
grade? What kind of grade are you getting?
It's a C right now because there's a couple quizzes I still have to make up from golf stuff.
Okay.
So that
It,
they're not hard.
okay, but you feel like you're understanding it better?
Yeah.
Good.
I'd probably have to drop out of the class if I didn't have you.
Well, I think you have good math skills. I do.
The way that my teacher explains it is way weird.
Well, the solution really lies in doing problems. Regardless of how poorly your teacher teaches, if you can at least understand it to a point where you can practice and do problems successfully, then that's what's important, and that's what will be important to you. So whatever you need to do to be able to get so you can at least do a problem successfully and then just practice doing them until it locks in your brain. And you're pretty smart. You have a good memory. I think you could probably use a little bit of practice on your arithmetic skills, but not a lot. You showed me just now today that you actually were pretty good at them. All right. You got anything else you want to cover today, Mitch?
Let's look. No. The rest of it I can understand with just doing this.
Okay. Shall we make your standard appointment just a half-hour appointment?
Yeah.
Let's do that. Let me go ahead and change it here. And if you ever have a day where you feel like you need the full hour, just call me or something. And it's not very likely that that spot's ever going to get taken up, but the moment I open it up, somebody could always go in there and change it. I mean, seize that 10:30 spot. So if you think you're going to need an hour someday, or you could even go online and schedule that 10:30 spot yourself. Know what I'm saying?
Yeah.
All right. I will talk to you next Saturday at 10. Okay?
Yeah.
Have a good one. Bye-bye.